remains constant. We know that value of a unit of money is different in different time periods, meaning thereby whatsoever money we receive today has much value than value of money received in the future. Reason being that money received in the future has investment potential. So a unit of money which we receive today has much value than compare of money received in the future, because we are going to use that money, we are going to invest that money. So the money which we are going to receive today, we have to assess present value. The money which we are going to receive in the future, we have to compute future value. But we always, we if we find out the present value is quite less, future value is quite high. Reason is that present value goes for investment and makes the future value, but the importance of money and the worth of money present is quite high compared to future because of investment potential. Now, while computing present value or future value, we use the rate of interest. Now, the rate of interest has three components. Number one, the real rate of interest. Number two, inflation effect. Number three, risk premium, which we have already discussed under risk-free rate of return plus risk premium. So if we talk about interest rate has three components. Number one, rate of interest real plus rate of inflation plus risk premium. So these three components are used to find out present or future value. Now, if we talk about present value, we go for discounting. If we go for future value, we go for compounding, because in present normally value is less, because value will go up when we use the money for investment, so it is discounting. But in the future money is compiled up or compound, so it is compounding. So that is the basic concept of time value of money. So if we draw time value of money, that's the diagram is very well explained. So we have compounding and we have discounting. Now discounting is present and compounding is future. So you look at coins are discounting. If we club the money goes for investment, money is compiled, so becomes compounding. So we have discounting and we have compounding sums. Now, so we have today and we have future. We know that receiving dollar today is worth more than one in the future. So it is worth, I'm not talking for value. Worth is high. Why? Because the money which you are receiving today or dollar which you are receiving today has opportunity cost. So opportunity cost of this dollar one is the interest which could have been earned if we have received the dollar one sooner. It means that if we receive money just now, we can earn the interest. So the dollar one would have become dollar two or dollar three in the future. So opportunity cost is counted in terms of interest that can be earned by using that money or by investing that money. Now, if we want to measure this opportunity cost, what we can do, we can go for compounding. So translate dollar one to equivalent in the future. So what I do, I will do my compounding formulation. Compounding means what? Your cash inflow into 1 plus rate raised to power time. Similarly, this is compounding. Compounding means your money is compounded. If I want to compute, so I'm moving from today to future. On the other hand, if I want to move from future to today, that is discounting. So I'm converting dollar one in the future to present. So what is the value of dollar one after a year is compounding. What is the value of dollar one received after 1 year at present is discounting. So if I want to calculate present value, it is discounting. If I want to compute future value, that is compounding. So we have two kinds of techniques valuation. Number one, compounding. Number two is discounting. That is the part of your time value of money. Now, let's see in detail future value, which is the very important technique of time value of money. So that is the part of your unit 3. Now before I complete unit 2, in In unit 2 we have seen what is the basic concept of time value of money and what are the various techniques we have studied. Number 1, present value. Number 3 is Number 1 is present value, number 2 is future value. Now, before I discuss unit number 3, in unit 3 we'll be talking in detail how present value is assessed, how future value is assessed. Now, while we talk about present or future, we have one more concept called as doubling period. In doubling period, we have two rules, rule of 72 and rule of 69. 72 means that how much time will take to double your money. So as per rule of 72, we use 72 by k. So if rate of interest is 12, right, so what we do, we'll do 72 by 12, right, it comes to 6 years. So within 6 years your money will be double. Now if we follow the rule of 69, it is 0.35 plus 69 by interest rate. So if rate of interest is 12, so 0.35 plus 69 by 12, it comes to 6.1 years. So in doubling period, we may follow the rule of 72 or rule of 69. 72 means 72 by k, 69 means 0.35 plus 69 by k. So this is the rule of doubling period, that is the part of time value of money computation. Similarly, we know that the rate of interest we keep on compounding. So because money is multiplied in the future, so we have to calculate effective rate of interest. Effective rate of interest is normally because of doubling period, giving the effect of compounding. So if your rate of interest is 12, compound is that we are giving interest on interest. Normally we compute this, so the effective money earned by you would be quite high than 12% rate. So if I want to compute effective rate, I use the formula, that is R is equal to 1 plus k by m raised to power m minus 1. So formula is 1 plus k by m bracket raised to power m minus 1. Here k indicates rate of interest, m is the frequency of compounding, meaning thereby how many times you compute the interest. Suppose the rate of interest is 12 and I compound 4 times a year, so quarterly compounding. So my value of r will be equal to 1 plus 0.12 divide by 4. So only 1.12 divided by 4. So 1 plus 0.12 divided by 4 bracket raised to power 4 minus 1. If I solve the value, I got it 12.6. So I find that my effective rate of interest is quite higher than compared to future. So compounding gives me an effect of value enhancement. So these concepts are very much useful while computing present value or future value. Now let's go for future value assessment. Look at the example now. If you are depositing $100 at present, rate of interest 6%, how much you will receive after a year? So what's my present value? 100. Rate of interest 6 times 1 year. So how do I compute? Let's see its computation. If I want to go it mathematically, what I will do? 100, right? I got 6% interest, so rupees 6. 100 plus 6, 106. But if I want to go it mathematical solution, what I will do? Number 1, either I can use table. Table will be future value interest table, which is a single sum table or multiple sum table. But understand, you are not depositing equal money each year, so you can't use NUT table, right? So 100 multiply by future value interest factor, right? So interest factor you will look 6% for year 1. So the table is future value interest table, right? So 6% for year 1, factor is 1.060. So 1.060 into 100, 106. If you look at the table, if you want to go for formula, formula is present value into 1 plus rate raised to power time. So 100 into 1 plus 0.06 raised to power time is 1. I got the value 106. So you have three ways you can do it: manually, you can use table, and you can use formula. But please clarify, or please understand, you can use table only when the rate is in round figure, because the table is specifically for round number of years and round rate of interest. So 1, 2, 3, 4, 6%, and so on. Similarly, years are 1, 2, 3, 4, and any number of year, but in complete point, not in decimal, not in fraction. So only then you can use future value interest table, or future value interest factor, or compounding sum table. Now, similarly, other example, if you take number of years are 5, same amount $100, 6% interest. Similarly, you can calculate, value comes to 133.82. Similarly, you can go for mathematical solution, same. We can use table or we can use formula. If formula I use 100 into 1 plus 0.06 raised to power, now time is 5. Value comes to 133.82. So future value can be computed for single sum, right? If you go for quarterly compounding, I said earlier, you can have quarterly compounding, annual compounding, or semi-annual compounding, right? So 100 rupees, $100, but the rate of interest you are compounding on quarterly, right? In that case, your future value comes to 134.68, a bit high, because you are calculating interest 4 times a year. So that comes under your quarterly compounding. The formula which I said earlier, in case of quarterly compounding, you have to use a mathematical formula. Mathematical formula is future value is equal to present value into 1 plus I, rate of interest by m. M is frequency of compounding, how many times you calculate interest or compound interest. So quarterly 4, semi-annual 2, right? Raised to power m into n. N is the number of years. So here we have 5 years. So 5 into 4, 20. Right? Rate of interest is 6%, divided by 4. So value comes to 0.015. 100 into 1.015 raised to power 20. So we use the formula for quarterly compounding, PV into 1 plus I by m raised to power mn. Similarly, if it is half yearly compounding, here m will become 2. So 2 into 5, we will take the power 10. So accordingly, here m changes. Half yearly m is 2, semi-annual, sorry, half yearly or semi-annual value is 2, quarterly value is 4. That's a basic part of your single sum. On the contrary, if we go for monthly compounding, value comes to 134.89 for future. But if we go for mathematical solution, your power will be now m is 12. So 12 into 5, 60. Your m will become 12. Similarly, I by m. So 6% divided by m is 12. So value comes to 0.005. So 1 plus 0.005, 1.005, and power will be 60. Why power is 60? Because you do 12 into 5, 60. That's where you compute future value, maybe for quarterly compounding, monthly compounding, half yearly compounding, but it's applicable only for future value assessment. Similarly, its other example is your continuous compounding. So what is the future value of $1,000 earning 8% with continuous compounding? If we do continuous compounding, we can use the formula PV into E raised to power IN. So the rate of interest is 0.80. We find the value of E. So future value comes to 2980957. That all comes to your future value. But if we talk about future value for annuity, formula will remain same. But in case of annuity assessment, the formula is slightly modified. So in case of annuity, FV is equal to PV into 1 plus K raised to power n minus 1 upon K. Formula is slightly changed. So FV is equal to PV into 1 plus K raised to power n minus 1 upon K. Suppose rate of interest is 12 and amount is 100, but you are depositing $100 each year for 5 years. So 100 into 1 plus 0.12 raised to power 5 minus 1 upon 0.12. So that is annuity. Else what you can do, you can do PV into FVIFA, future value interest factor assessment, or future value interest factor for annuity. So if you want to use table, you have to use a annuity factor. So that's why you compute future value for single sum, multiple sum, or annuity. Next valuation technique is your present value. Let's go for present value. Present value is exactly opposite of future. In future, money is multiplied or money is compounded. So I do FV is equal to PV into 1 plus I raised to power time. But in present, money is discounted. So what I do? Future value divide by 1 plus rate raised to power time. Because future is multiplied, so we multiply, but present money is discounted, so we use division. Let's see an example. If you are receiving $1 after 1 year, earlier we are investing today and we are asking for future value. Now I'm asking saying that you are going to receive $1 after a year. What is the value at present if rate of interest is 6%? Right. So I want to compute present, but future is 100. So if we look at solution, my PV comes to 94.34, slightly less. Why? Because 94.3 will become 100 only after a year if it earns 6% rate of interest. Let's look at now. If we look at its mathematical solution, the solution is either by table or formula. If you look at table will be future value into PVIF, present value interest factor, but not annuity, because you are depositing only, you are receiving money only once, right? But table can be used only when you have a round rate of interest and defined number of years without decimal or fraction. Now if you look at table, present value interest table, you will look at 6% for year 1, right? Value is, if we want to compute value 6% for year 1, your factor value is 0.943. So 0.943 into 100, right? Or what I do, future value divide by 1 plus rate. So 100 divide by 1 plus 0.06 raised to power 1. The value sim comes to 94.3. Or you multiply by factor 100 into 0.943, value comes to 94.3, right? That's why we compute present value of single sum, right? If number of years are suppose 5, then my PV comes to 74.73, slightly more or less, because years have increased. If you go by mathematical solution, what we can do now, 100 divide by 1.06, now raised to power 5, not 1, because years are now 5. So in case of present value, we don't have compounding, either monthly, quarterly, semi-annual. Why? Because money is not multiplying, or money multiplier is missing. So we use only simple formula FV divide by 1 plus rate raised to power time. If we want to compute present value of annuity, right? The best way out is future value into present value interest factor annuity. Now you look at annuity table. Suppose you are suppose you want $100 every year for 5 years. What is the present value now? So $100 multiply by present value interest factor annuity, right? So that's why we compute. So present value, if we look at annuity table, 6% is value is changed, right? So it is around 1.83. So if we talk about annuity value, you can use annuity table. If you want to use without annuity, you will use PVIF table or present value of rupee table, but annuity will be used only when you have a constant value every year, right? Other example, what is the PV of $1,000 to be received after 15 years, right? Now nothing to worry, your PV value comes to 362.45. Nothing, a slight change, right? What change? Only number of years. If we look at mathematical formula, simple, 100 or 1000 divided by, sorry, its value is 100 in the question. So 100 divided by 1.07 raised to power now 15, hardly. So what is changing? Only number of years. So in nutshell, in future we use the formula future value is equal to present value into 1 plus rate raised to power time, or PV into future value interest factor if without annuity. If with annuity, then PV into future value, sorry, PV into future value interest factor annuity. If we want to compute PV, PV is equal to future value into present value interest factor, or if it is annuity, then PV into PV into present, sorry, FV into present value interest factor annuity. So we have two cases, either we have annuity or not, both for present or future, but present is compounding, future is discounting. So this unit 2 and unit 3 gives me a clarity about time value of money computation. We have done doubling period, rule of 72, rule of 69, effective rate of interest, compounding, discounting, but time value of money is very apparently used at present point of time while assessing